Hey guys, and welcome back. Today I want to go over the FRQ answers to your Unit 1 test so that you guys can kind of identify where you got your points and where you missed them. And then if you have any questions or want to go over your test individually with me, we can definitely set up a Zoom meeting for that. So I'm just going to go ahead and jump right into it. Our first question, actually, the grading rubric was a little bit off, so it has 9 points instead of 10, so everybody automatically got an extra point on this one. So you got 1 point for free on number 1. But then let's go ahead and break down the question. So A says nitrogen is the largest percentage of the atmosphere. However, atmospheric nitrogen cannot be used by producers. Describe how nitrogen is converted into a usable form by photosynthetic organisms. So basically here is 1 point. You had to explain that nitrogen is fixed into a usable form by nitrogen-fixing bacteria in the soil. And then once converted, the plants assimilate the nitrogen and use it for growth. So what I was really looking for here was that you use the word assimilate, because that's how the plants take it up. They assimilate it into their tissues and they use it for their own growth. And then you need to mention that the nitrogen is fixing the bacteria is fixing the nitrogen in the soil. So it's not a usable form, obviously, in the form of nitrogen gas in the atmosphere, so it has to be fixed first. And then B, I was very lenient on B because it says identify the type of interaction occurring between the producers and the nitrifying bacteria. It's a mutualistic symbiotic relationship. A lot of you guys had that, but some of you went on to explain, again, some of you mentioned the assimilation in part B as the relationship instead of putting it in part A. And if you did that, I gave the points to you as well. But when we talk about interactions, remember species interactions are things like mutualism, commensalism, things like that. I was also lenient, and if you had commensalism, I counted that as well, even though it is mutualistic, because commensalism, remember, is when one is not harmed and then one organism gets a benefit. So I guess if you were looking at it from the view of the plant is the one getting the benefit from the uptake of the nitrogen, then that would be commensalism, but the bacteria are also benefited, so it is mutualistic. So I mentioned before I was very lenient in grading these, but this is just what the correct answer should have been. C says discuss how human actions have changed the amount of carbon available in different reservoirs. There are many different possible answers here. I just have a few. So if you don't see it on here, it doesn't mean that the one you had wasn't correct. It's just these are some of the examples. Now, a lot of people lost points on this one because they didn't explain what was happening to the reservoir. So a lot of you said, oh, we're burning fossil fuels, but you didn't say that the fossil fuels were leading to the depletion of carbon in the sedimentary rocks. Or you didn't say that combusting fossil fuels was adding carbon to the atmosphere, adding carbon to the ocean. You just have to be very mindful of your explaining what is happening. So which carbon sinks are losing carbon and which ones are gaining carbon. So burning fossil fuels removes carbon from reservoirs within the earth, but adds carbon to the atmosphere in the form of CO2. Increased CO2 in the atmosphere will be absorbed into the oceans, thus adding carbon. Deforestation releases CO2 in the atmosphere and reduces the amount of producers available to absorb the carbon. And then cellular respiration also adds CO2 to the atmosphere. This is less of an impact, but we as humans do add CO2 through our respiration. D was identify the major reservoir of phosphorus. That was sedimentary rock. I did accept just rock, but it is sedimentary rock. And then E says, discuss why phosphorus is a limiting nutrient in biological systems. A lot of you guys lost maybe 1 or 2 points here because you didn't explain what a limiting nutrient was. You didn't elaborate enough. So the phosphorus is a limiting nutrient in part because it's not very readily available naturally. So the rocks have to be weathered. There's not a lot available. It's not soluble in water, and there's not an atmospheric component. But we have to elaborate, because this is a discussion. We have to say that phosphorus is the limiting nutrient, and the reason it's a limiting nutrient is because it is what controls the growth in plants. So it's a limiting factor because it is what is controlling the growth. So without it, the more you have, the more growth you can have, the less you have the less growth of the plants that you'll have. So a lot of you were just missing that like extra little detail of why it's a limiting nutrient. A lot of you said it was a limiting nutrient because there's not much of it, but it's actually a limiting nutrient because the amount of it will determine how much growth is in plants. Okay, so moving on to question 2, which was on gross primary productivity. And A says, identify one biome that has high productivity. The number one answer was tropical rainforest. I'm pretty sure everybody got that right. It is the most, but a lot of the terrestrial biomes are very productive. So chaparrals, temperate forest, anything with large amounts of producers and vegetation would have been acceptable. Describe why the biome has high productivity. This was worth 2 points. A lot of people lost 1 point because you didn't explain that they needed sunlight for photosynthesis. So yes, it's true that tropical rainforests are very productive because they get large amounts of sunlight and they have large amounts of water, and also availability of just like the temperature is very warm. But you have to say that all of that is necessary for photosynthesis for the production of the energy. So a lot of you had the first part right, you just didn't mention photosynthesis. So if you lost a point there, it's because you didn't mention photosynthesis. And then here's our math for C. It says the annual primary production or productivity of a particular rainforest ecosystem is found to be 4,000 kilocalories per meter squared. If respiration by aquatic producers is 20,000 kilocalories per meter squared per year, calculate the gross annual primary productivity for this ecosystem in kilocalories per meter per year. 1 point for the setup and 1 point for the correct GPP. So the net primary productivity is going to be equal to your gross primary productivity minus the respiration. So our net primary productivity here was 4,000, and then our respiration was 20,000. So we have 4,000 on the left, 20,000 on the right, and then in order to balance the equation, we will add our 20,000 kilocalories, and we should come up with 24,000 kilocalories per meter squared as our gross primary production. And again, 2 points, 1 for the correct setup and 1 for the solve. Some of you guys had the right answer but didn't put your math, and so if you lost points there, that's why. The gross primary productivity of an ecosystem is 2.5 kilograms per meter squared per year, and the energy needed by the producers for their own respiration is 2.0. Calculate the net primary productivity. Net primary productivity is just gross minus respiration, so we're going to take that 2.5 and subtract the 2, and then we should get 0.5. Some of you guys made this more complicated than it had to be. I think as AP students, you look at something and think, it can't be that simple. So you go a roundabout way to do something, but it is just as simple as subtracting the 2 from the 2.5. And then discuss why primary productivity decreases in lower layers of aquatic ecosystems. Again, you just need to say that sunlight can't penetrate into those zones, and you need sunlight for photosynthesis. A lot of you actually mentioned photosynthesis in E, but you didn't in the first part, so you lost a point for not mentioning photosynthesis in B, but then you got it in E. So, and if you did not mention photosynthesis, if you just said that the sunlight couldn't reach, but you didn't explain why it's needed for photosynthesis, then you lost a point there too. And then finally, our last FRQ for 1, 2, and 3, you get 3 points for identifying. You only had to do 1. A lot of you did more than 1, but only 1: producer, primary consumer, and secondary consumer. So the producers are the grass, the shrubs, and the trees. Some of you guys lost points here for saying fungi. Fungi are eukaryotic, and that's just like previous knowledge we have to have from biology. Fungi are eukaryotes. They don't do photosynthesis. And again, since only 1 answer was needed, if you put fungi first, but then you had the other right answers, you still lost the point because that's the way that they'll grade it on your AP test. So fungi is not a photosynthesizer. It's not a producer. I'm sorry. It's actually a decomposer. But primary consumers, squirrel, wow, squirrel is not spelled right, that's okay. Squirrel, grasshopper, rabbit, deer. And then secondary consumer would be your shrew, your snake, your hawk, and your bird. Some of you said mountain lion. The mountain lion is a tertiary consumer, not a secondary. So if you put mountain lion as your secondary and got it wrong, that's why. And then finally, We have our math problems here. So we've got each grasshopper requires 2 grams of grass every day. Calculate how many blades of grass are required for each grasshopper every day if one blade of grass weighs 0.2 grams. And then again, you get a point for the setup and a point for solving. So the blades of grass would be equal to the weight of the grass needed divided by the weight of the grass itself. So we've got 2 grams divided by 0.2 grams, and then that's going to give us 10 blades of grass needed for the grasshopper. Again, 1 point for setup and 1 point for solve. And then B, shrews need 3 grasshoppers per day to survive. Calculate how many blades of grass are required to support a family of 5 shrews for 1 week. Some of you guys lost it here because you did the calculation per day and not per week. So again, 1 point for setup and 1 point for solving. So the blades of grass would be equal to the number of grasshoppers needed times the blades consumed by the grasshoppers. So the blade of grass for shrews would be equal to the 3 grasshoppers being consumed times the 10 blades of grass per day. That equals 30 blades of grass per 1 shrew per day. So then you've got to take the 30 blades per 1 shrew times a family of 5, which would give you 30 times 5, which will give you 150 blades of grass per day for the family. Some of you guys stopped there. So we have the 150 blades of grass per day per family, but then we have to multiply it by 7 days because the problem asks on a weekly basis. So then 150 times 7 will give us 1,050 total blades of grass to support a family of shrews. And again, that just shows you how energy moves up the trophic level and how eating at a lower trophic level can actually be more environmentally friendly. And then finally, D says, as human populations grow, more housing is needed. Trees will be cut down to make space for those homes. Discuss 3 possible impacts to this food web due to the removal of trees. So the impacts needed to be to the food web itself, some of you were talking about different things, but I mean, I was pretty lenient on this one too. If it was a logical consequence, then I gave you the points. But these are just some examples. Again, these are not the only examples you could have used, but if you have any questions about your own, let me know. So less energy available for primary consumers. Death or reduced population of primary consumers will lead to less food sources for secondary and tertiary consumers up the chain. Potential extinctions and die-offs up the food chain, and dissolution of the food web itself were some of the ones that I came up with. But yeah. That's it. And there were 3 possible points there. You needed to have 3 impacts on the food web in order to get those 3 points there. So those are the answers to your Unit 1 test FRQs. Again, these are where your points came from. So if you have any questions about that, or you want me to go over your particular test with you, I will absolutely be happy to do that. But if not, I hope this helped clarify some things for you, and hopefully will help you kind of prepare a little bit in the future for your future FRQs. If you have any questions, let me know, and if not, I will see you guys in the next one.